Tonight is November the 1st, 2018, and I'm going to do an experiment tonight, I guess is what it would be called. This is an amplifier, stereo amplifier that I built some time ago, and I believe I made about 7 videos of it, of its construction and what have you. Here's another one that I've shown on the YouTube several times, and this is one I've listened to for actually quite a long time. It's mono, it's one channel, it runs some 6B4s. It's basically an all triode 6B4 Williamson amplifier, 5AR4 rectifier, power transformer. It uses a little 8K primary James transformer. I've listened to this thing for a long time, and I play it out of these two speakers up here. One right there. I think they're Paradigm. I believe they're called Focus, and then the other one is right over there. They sound great. So I said, well, that's a mono amplifier. What if I go to a stereo one? So I put this one back in place, and this one performs beautifully, but it's something I can't explain. I don't even know where to start. I don't like the sound of this one as much as I like the sound of that mono triode amplifier. So I thought I'd try something. I've got a bunch of 6B4s, got 6 of them right here, plus the other 2 I just showed you, so I got 8 of them. And here's how I've tested them at some time or another. 58's the minimum, or 38's the minimum, 60 over 38, 57 over 38, 54 over 38. Anyway, this one says not good. Anyway, what I thought I would do is I'm going to put them into this amplifier. And by the magic of video, you'll see this amplifier, and then I'm going to make some changes and be able to plug these 6B4s in. The reason I can do it so easily is the plate connection on a 6L6. I know these are KT66s, but the 6L6 family of tubes has the plate on pin 3. So does the 6B4. It has the filaments on 2 and 7. This one's on 2 and 7. Of course, these are directly heated and these are not. This one has the cathode on 8. This one does not have a cathode on 8. It has the control grid on 5, the same as the 6L6, and the screen grid on the 6L6 is on 4, so it's just not used over here. So it's actually very close to being able to plug it in with a minimum amount of changes. Now here's what I drew up in an attempt to understand it. This is one channel, and here would be the other channel. Sorry for that glare. Let me turn that glare off. Let me turn a different light on. Glare is always a big problem in making videos. Maybe that'll be better. Yeah, there's one channel, there's the other channel, and there's the way I drew the filaments. I've only got one filament supply. I've only got one 6.3 volt winding right down here. So if you redraw it, it's like this. Everything's parallel, and it would have 2 resistors in here, so I said no, I don't need to do that, so I just need to take one out. But then this is one channel and this is another channel, and I don't know how well that's going to work. I think it's going to work. With this big capacitor across it, there's not going to be any audio on the filaments, so I think it's going to work. Normally this is about 850 ohms, but now I'm going to be drawing twice the current, so I think I need 425 ohms, thereabouts. So that's going to be my starting point. Yeah, here's a pinout for like a 6L6. See, the plate's on 3, the 6B4, the plate's on 3, 5 and 5, 2 and 7, 2 and 7, and a cathode on 8. We're not going to be using this one. So they're actually very close, and they're octal sockets, and all this plug right in. They would draw the same amount of current, I think like 900 milliamps. So I don't know if you guys think it'll work or not, but I'm about to find out. Now actually this amplifier right here is set up that way. I don't think I can show it to you safely. Well, I think I can kind of lean it up on its back side and show you. What I did here is I've got a cathode resistor right there, and I got another cathode resistor right up there. If you can see it there, yeah. See, that one is for, I think, the 6B4 connection, and this one down here is for the 6L6 connection. So this one right here, I can actually unplug those 6B4s and plug in 6L6s or 5881s, and it will work. and it works properly. Now the one big difference is you cannot run 450, 500 volts on these 6B4s without risking damaging them, and I don't want to do that. So the one thing I'm going to have to do over here, let's see if I can do the same thing. I believe I can. Lean it back. Yeah, here's underneath that guy. I went to a lot of trouble to make, see, this tube and this tube's the same tube in the different channels, the input. This is a driver tube, this is a driver tube. You can see that how this choke has, it's running at a little bit higher current than it should be. You can see it's getting pretty darn hot. But what I'll end up doing to lower the voltage is I'll end up disconnecting this capacitor right here, because see, here's a capacitor on the input of the choke, straight out of the power supply. Here's a capacitor on the output of the choke, which makes these two capacitors in this choke right here a pi filter. So I'll make it a choke input. That'll lower the voltage quite a bit, from about 125% of the RMS voltage across half of the winding to about 90%. So that should get it down at a safe value. Now this pot right here is the one I'm planning on using right now. I think it's 100 ohm. I'll have to check that. And right now it's a hum balance. But what I'm going to have to do is right off the center tap right here, put the bias resistor and bypass capacitor, the cathode resistor and capacitor. Put that off of there and remove this, and I think that's all I'm going to have to do. I'll have to measure it pretty carefully and make sure that it sort of works. I also want to take out these capacitors right here. I put these guys in to stop some anomalies up at 20 kilohertz and make the amplifier very flat. And I was advised by some of you guys that watched this video when I was building this thing not to do that. See, here's one over here too. They had to be different values, because I found out that for whatever reason, I don't know if it's vintage or quality control, you know, age or quality control back when they were made, but these little transformers, as beautiful as they are, and they do perform really well, I had 6 of them at one time, and no 2 of the 6 were exactly alike. And I find that kind of unfortunate. Again, I don't know if they're different because of age, or if they were different the day they were born. But anyway, here in a few minutes, I'm going to have made the changes to the center tap of that what is now a hum balance pot to a pot that will actually allow the 6B4s that I'm going to place in here to have a return path to ground through the cathode. And then I'll be plugging these guys in right here, plus the other 2 from the other amplifier. I know those other 2 are very good, and I guess I'll probably use like these 2 right here. Of course, I'd like to get 2 that look exactly alike. I got some 2A3s over here also, but I don't ever use those 2A3s. I find that 2.5 volt filament or whatever it takes just a little bit strange. For some reason, I'm not so charmed by that. There's some CRC 2A3s. I only have 3 of them also, so I've never used them. Maybe one of these days they'll go up so expensive on eBay I can send my grandkids to college on them. Well, you gotta plan ahead, you know. So let's see how this thing turns out. And I'm hoping that my newer Triode amplifier will, for one thing, it'll draw a lot less current, so it won't be near as hard on this power transformer. This thing gets really hot. When I built this thing, I did not plan ahead far enough. This transformer is not big enough. It needs to be at least 300 milliamps. I think it's 200. It's actually stamped on it, but we won't get into that right now. Okay, so think about it for a second, and you can contemplate in your own head what this is how this right here is going to perform, because that's actually how it's going to be hooked up. All filaments parallel, both channels, left channel, right channel, however you want to look at it, with one return path and bias back to ground. So it's going to have to bias all 4 of these tubes. It may be just peachy keen if these tubes are well enough balanced. Let's see what happens. Okay, a little bit of an update. I've disconnected these capacitors, which, like I said, were meant to solve anomalies up at the 20 kilohertz range. So it has no strange things in it anymore. disconnected the input capacitor. I'm just going to let it hang there. So I have a choke input, and here's coming off of the center tap, but I'm not going to use this pot. I'm going to hook in some weird stuff out here and hook them in with you know, all these little jumper cables up here, because I'm not sure how this is going to turn out. But I just realized something. This probably is not going to solve my problem of current of the transformer. The transformer is indeed rated 200 milliamps, but if you look over here at the sheets of a Class A amplifier, you'll see right there that each tube wants to draw about 60 milliamps plate current. Well, 6 and 4 is 240 milliamps, so with these 6B4s in there, this thing's going to be running Class A1. It's going to be drawing actually more current than the 6L6 style tube is, but I'm still going to go for it. We'll see. Alright, some quickie results here, preliminary results, however you want to look at it. Well, I adjusted that hum pot in the middle, which I think is 100 ohms, to right in the middle, so I'm basically not using it anymore. And I came off of each side with two 10 ohm resistors. That's how I tie the two sides of the filament together, right here. It's going, this is a 1K 100 watt resistor. It looks like I've got it adjusted at about 450 ohms, and it's bypassed with this 100 microfarad 450 volt cap. And let's see, right now I'm driving the right channel, and at about 2 kilohertz I'm getting 6.5 watts right at 1% THD. There's the voltage across the 8 ohms. If you square that and divide it by 8, you'll get that number. There's what it looks like. Let's auto do this again. Looks like it's got some hum on it. Yeah, look. See right there, that's the arrow voltage. I hope you can see that it's not washed out by the brightness, but I see hum in there. So I've got to deal with that a little bit. But and I'm sure that's bringing the THD up. You don't see it so much on the sine wave, but it's there. You can see it. So just right out of the box, that is the way it's performing. And the right channel, I believe, the way I've got it fixed up, something had to be switched in here. I don't remember which. I think this is the right channel, actually. Doesn't really matter. Well, these are the two tubes that I know are really good, and these are the two that I'm not so sure of anymore. I'll have to very lovingly check each one of those. I will make one more video, one more pass at this, and when I get it as best I think I can. Right now I've got the bias voltage up. Let's turn it all the way down. I got the bias up pretty high at about 53 volts. It's on a 60 volt scale. So I got the bias set kind of high. Yeah, I can adjust it by sliding this guy down a little bit. But then I'm going to start drawing more current. So I've got to kind of think about this, because one of the objectives was not only to end up with an all triode amplifier, push-pull 6B4s, but I also wanted to reduce the load on this guy right here. But it doesn't look like I've done that yet. I'll have to do some measurements and see. But anyway, this is some preliminary results, and it's actually looking pretty good. Okay, a couple of other measurements. 53 volts bias, and this is encouraging. This is on a 120 milliamp scale, so this is actually only about 106 milliamps. Now that's encouraging. With whatever that resistance is right there, I don't know what the plate voltage is yet, and that is going to make a big difference. But the current draw is really encouraging. That'll keep this transformer from getting so doggone hot. I mean, it gets hot. So there we go. That's a good sign. I'm really pleased with that. Here's its output. Yeah, you can see that hum again. You can see that that's got to be fixed. I bet I'm gonna have to separate the filaments, maybe put in a filament transformer for each side. That's a guess right now. I don't know why, otherwise I would have so much hum. Okay, here's something you might find interesting. I clipped that capacitor back in right there with that one of those white jumper wires to make it a pi input filter again instead of a choke input. It raised the plate voltage to 465, which is a little bit out of whack with the maximum voltage for a 6B4, but look what it does to it. It raises the power output to 16.5 watts at a good bit less than 1%. Seemed like it even reduced the hum. Probably did. Pretty amazing, huh? Well, I don't know. Maybe I'm going to leave it like that. I'll be running those 6B4s hotter than hell, but that's what I ran the KT66s at. By just going from a capacitor input filter, pi filter, to a choke input filter. So that's something to digress a minute. That's something I've actually tried to point out a number of times in my videos is even with a fixed power supply, you have more than one option by choosing your filter, whether it's choke input or a capacitor input. And then oftentimes you may have taps on your primary. You can go from a full wave center tap to a bridge to a doubler. So you have 6 or 8 options out of every transformer. But anyway, look at there. That's not bad, huh? 16 watts. I kind of like that. Looks pretty good. That's one channel. I think I'm going to, and look at the current. The plate current for all 4 of them is 100 milliamps. I think I'm going to put it in there. I've got this resistor all the way up to close to 1K. So I think I will do a little bit of math here, R equals E over I stuff, and find out how much power has been dissipated in this resistor, put something in there smaller, just kind of tack something in underneath so I can hook this jewel back up and see if my ears really do love triode amplifiers more than pentode amplifiers. There you go. Let's see what happens next. Well, here it is, finished. I've already hooked it up, turned it on, measured it, played it. It is magnificent. I cannot understand what the difference is in the way that I perceive the sound to be, but I love it. I love these triode amplifiers. What I did, I think I showed you in the beginning. Actually, I hooked the I hooked the pi network back up. My voltage was just too low and I wasn't getting enough power out of it. I'll show you the power. This one right here, I don't remember if this is 50 ohms or 100 ohms. I think it's 50. But anyway, I left it in there. I did the math. It's okay. There's not enough current flowing through it to hurt it. Here's the bias resistor, 850 ohms. There's the bypass. I removed all these other capacitors that I put in there to tame this thing up at the 20 kilohertz and make it past the 0.5% THD level up there. So let me show you the top of it. Okay, got it hooked up to the dummy load. Here's the dummy load up here, two big non-inductive 8 ohm loads that I can switch back and forth, left channel, right channel, etc. Goes over here, feeds this thing, and this is a breakout box which feeds all the equipment. This is voltage, this is THD, frequency, and power, and then just a oscilloscope display. I've got it into the right channel right now. I'll crank it up. There's the, we'll watch that until it starts to clip or flat top or something. See, it's clipping there. You can see the top and the bottom, nice and symmetrical. Turn it back down to below that. And then I adjust the THD to 1%. There you go, 1%. 16.5 watts. That's what it does. If I do the other channel, it's not quite as good. It does move exactly with the output tubes. These are the right channel output tubes. I use fingernail polish or gold paint or whatever. I put gold on this one and this one because those are my two best ones. I put yellow on these. You know, it'll come right off. But I use different color fingernail polish to mark things. This is the left channel. This is the right channel. Left channel input's right here. Right channel input's right there. The only place that they're switched is on the back because I didn't want to run wires from here to there and from there to here, you know, from the output transformers. But if we go to the left channel, we switch the dummy load up here, because I think most of you have seen this, but for somebody that hasn't seen all this before, this is the way it's hooked up. Here are some adjustments for feedback, which I have not touched yet. See, right channel goes to this one. I have two markers on this one to designate the right channel. The one with the marker on it on the single wire is the hot, the other one's ground. So there's the left channel. AC on off switch, and my markings, and I like to decorate it up. Some of this kind of hardware I get off of pieces of equipment that I've salvaged, and I highly recommend using these things nowadays. They're a little bit more trouble to install, these female AC receptacles, but to not have this wire dangling on it while you're trying to move it around is such a blessing. You disconnect the wires, you unplug the input, and then this thing is so easy to move around. Anyway, you saw the right channel. Now we're in the left channel. Like I say, we switch our dummy load up here from that's left channel, that's off, that's the right channel. And the left channel does not perform quite as well. We run it up to, say, a clipping level of about right there. Looks like I see a little bit of notch distortion in there too, actually. These tubes are not quite as good. If we turn it down below there and we set it at just at 1%, it does 12.6 watts. So it's a little bit weaker. This is all of the kilohertz, but it just sounds, it's stunning. I cannot understand why this little amplifier at only, I'll call it 15 watts per channel, has the sound that it does, that I so much prefer over these beautiful, absolutely beautiful KT66s. Now, I buy these KT66s, I think, from Tube Depot, and these right here are just made in heaven. There's some of my really weak 6B4s. They're really not worth using, but I'm going to keep them anyway. These KT66s perform exceedingly well. And they perform so well that, oh, I don't know, maybe a year ago, I've had these a couple of years, I ordered another set, and they were absolutely terrible. Absolutely terrible. Sent every one of them back, and they gave me all my money back. They're a good outfit to do business with, but they must have had a bad run of them, and it was in this amplifier right here that performs very, very well. And even with these 6B4s in there, the sound of it is just magnificent. I know I got a question the other day. The fellow said, well, but how does it sound? And I usually don't comment on that because I always think they sound pretty good. But as I mentioned in the very beginning of the video, this guy right here just sounds so darn good. I said, I gotta go stereo. And I did, and there it is. Let me turn out some light so you can see it a little bit more in the dark. The filaments, these filaments look actually quite different. These are pretty bright, huh? These are not so. But those are the best tubes right there. These tubes actually outperform these. 6SN7s, driving it. I'm trying to focus there, not quite enough light. Let's see, let's get it to focus again. I hate out of focus stuff. There we go. Well, that's it. I wish I could play music for you and you could hear it at the level that I hear it here. But it's just, the detail is there. I guess that's what it is, and I guess that's what I like about it. So I hope I don't run the price of 6B4s through the ceiling on eBay. They're already expensive enough, and these are original, guys. These things were probably made back in the 40s. I can't think of anything else right now I wanted to show you. I showed you underneath there. Not much else to do. Let's unplug it. Take one more look at it here. Yeah, and the total current is just a little over 100 milliamps. So I've had it playing for a good while, and the transformer, look at there. I can keep my hand on it. It's warm. It's real warm. But I could not do that. This thing got screaming hot. Unhealthy hot. Trying to run those KT66s. And so I've got the cathode current down really low. The bias is up around 90 volts, around minus 90 volts. So I've got a lot of what we might call headroom as far as driving it. I don't know what the actual RMS voltage is out of here, but the RMS voltage, you have to convert it to peak by multiplying it times the square root of 2, 1.4 and 4 thereabouts, because you cannot exceed the bias voltage, the negative bias voltage, with a positive peak, or you will be driving the grid into conduction. And the definition of Class A is you never shut off the plate current. That's the definition of it. It means that you never drive the grid so negative, which is actually going in the opposite direction, that you turn the plate current off, because then you get all kinds of anomalies in there. And by the same way of looking at it, you actually never draw the grid positive either, so that you draw grid current. So maybe that's the difference. This amplifier now is running Class AB1. Not Class AB1, I'm sorry, Class A1. Class A. Pure triode Class A. Just has a sound in it that I can't describe. I think I'm going to probably end up putting it in there on my theater and see if I hear the big differences in there. Well, anyway, I hope that you guys enjoy this stuff. I hope it's worth something. It's fun. I really love doing this, and I just think these things are beautiful. So I can't think of anything else going on right now. So I'll end this and post it. Thanks for watching, and I sure appreciate any constructive comments, because I always learn from you guys, everybody as much as you do from me.